Everyone, welcome once again to this online physics class for class 9. Today we will start revising this chapter, that is chapter number 10, gravitation. So the revision is in the form of multiple choice questions. Optional answers are given and we have to choose the correct answer to the question given there. So we have finished with this chapter long back, and I've been doing revision for the same chapter. So for the upcoming test you will be having this lesson. So kindly pay attention and start learning from now on. Okay, so let's start now. The first question. The force of attraction between two unit point masses separated by a unit distance is called. The optional answers are gravitational potential, acceleration due to gravity, gravitational field strength, universal gravitational constant. So the answer is option D, it is universal gravitational constant, because this is talking about the force of attraction between two unit point masses separated by a unit distance. This is called as universal gravitational constant. Now, second question, the value of G, that is small g. What is small g? Acceleration due to gravity. On the surface of the moon is what? See, the options are same as on the earth, is less than that on the earth, is more than that on the earth, keeps changing day by day. We are talking about acceleration due to gravity on the surface of the moon. So the option would be option B. It is less than that on the earth. Okay. Next question. The weight of an object at the center of the earth is what? A dash is given there. This you all remember when we were talking about value of G at different surfaces of the earth, that is above the surface of the earth, below the surface of the earth, on the earth, at the center. We had discussed this point too. So the weight of an object at the center of the earth is what? Is it 0? Is it r times the weight at the surface of the earth? Is it infinite? Is it 1 upon r square, the weight at the surface of the earth? The answer would be 0, because we are talking about the center of the earth. The value of G at the center of the earth would be 0. Next question. Two objects of different masses falling freely near the surface of the moon would be what? Will they have same velocities at any instant? Will they have different acceleration? Will they experience forces of same magnitude, or will they undergo a change in their inertia? See, when two objects of different masses are falling freely near the surface of the moon, they would have same velocities at any instant, because on the moon it is totally different. It is not like what is happening on the surface of the earth. Clear? Because on the surface of the earth it is a gravitational pull, but when we are talking about moon, we cannot talk about that at all. So two objects of different masses falling freely near the surface of the moon would have same velocities at any instant. Please pay attention to every word in the given question. Here it is spoken about moon. So in that case, the velocities will remain the same at any instant. Now next question. The value of acceleration due to gravity of the earth is same on equator and poles, is the least on poles, is the least on equator, increases from pole to equator. You all remember when we were talking about the shape of the earth, we had discussed all this. So what should be the optional answer for this question? The value of acceleration due to gravity, that is your small g, of the earth is least on equator. Okay, next question. Two particles are placed at some distance from each other. If keeping the distance between them unchanged, the mass of the earth of the two particles is doubled. The value of gravitational force between them will become what? Will become 1 by 4 times, or half a time, or 4 times, or 2. This we had done when we were solving those numerical parts. Such type of sums were shown in that. So when you are doubling here, the value of gravitational force between them will become 4, that is will become 4 times. Okay, now next question. In the relation F is equal to gmm by d square, here it can be r square even, because it's talking about distance. The quantity G, that is capital G. What is capital G? Your universal gravitational constant. So in the relation F is equal to G capital M into small m upon d square. The quantity g depends on value of small g at the place of observation, is used only when the earth is one of the two masses, is the greatest on the surface of the earth, is of the same value irrespective of the place of observation. Obviously, the quantity g will have the same value irrespective of the place of observation. It's a standard value. Okay, so when we were doing the lesson, when we were talking about capital G, small g and all, we had given the values there. Okay, so please keep revising. You have enough time for your exam, upcoming exam. So keep revising, keep learning, reading your textbook every now and then. It will be of great help to you while answering the questions given during the exam. Now, next question. The SI unit for acceleration due to gravity, that is small g, is it meter per second, is it centimeter per second, or meter per second square, or none of the above? Simple. The SI unit for acceleration due to gravity is meter per second square. Now, next question. A force of 20 Newton acts on a body of weight 9.8 Newton. Find the mass of the body whose acceleration due to gravity g is equal to 9.8 meter per second square. A force of 20 Newton acts on a body of weight 9.8 Newton. Find the mass of the body whose acceleration due to gravity g is equal to 9.8 meter per second square. Here I want you to do some work. See, there is no point in me solving and showing the sums again and again. Such type of sums were solved during the session in which the numericals were solved and shown. Okay, so please make use of that and you try to solve. In the next class, I will solve the same thing and show you, because you have to learn by yourself. That is more important. Okay. Next question. The answer is already given here. It is 1 kg. Please solve and see. Please see the revision videos, or you can look at the sample problems given in your textbook. You can solve and check for the answer, or in the videos which were presented earlier which contains numericals, the same thing is solved and shown. Such type of sums are solved and shown there. Okay, you please try. Now, next question. Same here also, you have to solve and see this even. Anyway, in the next video, I'll be solving and showing these two sums. Please don't wait till then, because I want you to revise. I want you to learn. Then only it will stick or stay in your memory for a longer period of time. See, a stone releasing on the ground has a gravitational force of 20 Newton acting on it. What is the weight of the stone? Given small g is equal to 10 meter per second square. They are asking about force. Okay, so weight is nothing but what? What is your weight? We have learned this, right? So, a stone resting on the ground has a gravitational force of 20 Newton acting on it. What is the weight of the stone? So, the answer is 20 Newton, because we are asking the weight. So, what is weight? How will you describe weight? When you recall all those things, you can answer this question easily. Okay? This question, you all should remember one thing. I've asked the weight of the stone. Weight of a body is nothing but the force with which it is attracted towards the center of the earth. Right? So, here you have to just give a thinking. That's it. Okay? Anyway, you try to solve. I will do this 9th and 10th question in the next class. Okay? Because we have done enough sums of this type while solving the numericals. You try by yourself. Anyway, I'll be taking up these two sums and solving and showing you in the next question. Here there is nothing much to solve. You have to think and answer. You just give a try, or else it's going to come in the next video. Okay, so till then you keep practicing these questions. Start reading your textbook. Take care. Bye and have a nice time.